welcome back to the stream. I'm Jared. If you're new here, I'm a Rubyist. I run a consultancy called Super Good Software, where we build e-commerce systems using Ruby on Rails and a platform called Solidus. This month, I'm going through all of the Advent of Code Christmas themed programming puzzles one by one. I've fallen a little bit behind, so while day 19 will come out at 9 p.m. Pacific tonight, I won't be around to do it. But I have not yet done 16, 17, or 18. I did 15, or I finished 15 earlier today after getting a little bit stuck on it, facing a bunch of performance issues, but we dug into using flame graphs to determine where my performance issues were, solved those, and came out the other side with a working implementation of Dijkstra's algorithm that worked for our puzzle. Took a little break, went and ran an errand. Now I've got eggnog. I've also got this, haven't tried it yet, but the tea that I had earlier I did not like. It was a green almond tea. This is much nicer. This is also a green with junk in it, but it's like an orange spice thing with like cinnamon and stuff. Kind of like almost like a chai made with green or something, with orange flavor in it. I don't know. It's not bad. A lot better than that weird almond one. So with that, let's get into it. Day 16, packet decoder. As you leave the cave and reach open waters, you receive a transmission from the elves back on the ship. The transmission was sent out using the buoyancy interchange transmission system, a method of packing numeric expressions into a binary sequence. Your submarine's computer has saved the transmission in hexadecimal. That's our input. The first step of decoding the message is to convert the hexadecimal representation into binary. Each binary character of hexadecimal corresponds to 4 bits of binary data. Apologies, my dog is barking in the background. The bits of transmission contain a single packet at its outermost layer, which itself contains many other packets. The hexadecimal representation of this packet might encode a few extra 0 bits at the end. These are not part of the transmission and should be ignored. Every packet begins with a standard header. The first 3 bits encode the packet version. The next 3 bits encode the packet type ID. These 2 values are all numbers. All numbers are encoded in any packet are represented as binary with the most significant bits first. That makes sense. For example, a version encoded as a binary sequence 100 represents the number 4. That makes sense. Packets with type ID 4 represent a literal value. Literal value packets encode a single binary number. To do this, the binary number is padded with leading zeros until its length is a multiple of 4 bits, and then it is broken into groups of 4 bits. Each group is prefixed with a 1 bit, except the last group, which is prefixed with a 0 bit. I have to reread this. I said all those words, but I'm not sure I understood all of them. These groups of 5 bits immediately follow the packet number. For example, the hexadecimal D2FE28 becomes this. And then it's a version, a type, and then a first one, and then a second one, and then a last one. And each one of these it's a 1 bit and 4 things, then a 1 bit and then 4 things, then a 0 bit for the last one, and then 4 things. Below each bit is a label indicating its purpose. The 3 bits labeled V something are packet version 6. The 3 bits labeled T100 are the packet type ID 4, which means it's the 5 bits labeled A start with a 1, not the last group. Keep reading. Yes. 3 unlabeled bits at the end are extra due to hexadecimal representation and should be ignored. So, I mean, I think it's pretty on theme here for Christmas themed puzzles to be doing, to have tea and eggnog. I think we're doing this right. So this packet represents a literal value with binary representation, blah, 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 which is 2021 in decimal. Wait, what? How do we get that? literal value. Oh, I see. We're just combining all the chunks of bits. Got it. Every other type of packet with any packet with type ID other than 4 represents an operator that performs some calculation on one or more subpackets contained within. Right now, these particular operations aren't important. Focus on parsing the hierarchy of subpackets. An operator packet contains one or more packets. To indicate which subsequent binary data represents its subpackets, an operator packet can use one of two modes indicated by the bit immediately after the packet header. This is called the length type ID. If the length type ID is 0, then the next 15 bits are a number that represents the total length in bits of the subpackets contained by this packet. A lot here. If the length type ID is 1, then the next 11 bits are a number that represents the number of subpackets immediately contained by this packet. Finally, after the length type ID bit and 15-bit or 11 finally, after the length type ID bit and the 15 or 11-bit field, the subpacket appears. For example, here's an operator packet with a length type ID 0 that contains 2 subpackets. I mean, I wonder how much we can just do this as a regex. Don't tempt me here. So we got a version, we got a type, we got, what do we call this again? Length ID. So we got 15 things here, which means that this, it's the total length in bits of the subpackets contained in this packet. And so that means that's going to be whatever this is. 11 bits labeled A contain the first subpacket, a literal value representing the number 10. 16 bits labeled B contain the second subpacket, a literal value representing the number 20. Not clear on how we tell how long these are. How do we figure this out? So I understand this says type ID is 0. Oh, right, because it's going to be 5 bits starting with a 1, 5 bits starting with a 0. I don't know why we have an extra 0. Why do I have an extra 0? Did I get that wrong? Why do we have 11 bits? Or these are subpackets, right? So it's 3 and then yeah, it is. I mean, we don't really even need, these are all just from doing previous puzzles. I just haven't closed them. Yeah, just a lot of words in here. Okay, we'll come back. We'll see how far we can get here. I won't get hung up. I'll come back and figure out what's going on. For now, parse the hierarchy of the packets throughout the transmission and add up all of the version numbers. Here are a few examples of hexadecimal encoded transmissions. Okay. I can turn these into tests. I'm going to use a vim macro. Whoops. What am I doing here? Key repeat too fast. How do I do this? Expect scribe class new solution to equal that. Oh, did that not work? Oh, we're good. Yeah. Let's just break these so they consistent here. And let's just focus this one for now. I think, or wait, so how do I do this? Can I do that? I mean, this isn't even valid syntax, so not pretty fair that you don't. I can do this though. Okay, that works. It doesn't give me a good way to focus them though. Can I do like focus true? No, that doesn't do anything. I just don't want to bother to do full separate context for each one, but fine, I will. Okay, now I can easily focus them if I need to. I'm just gonna make them nice and pretty. Let's start with this first one. All right. Represents an operator packet, which contains an operator packet version 1, which contains an operator packet version 5, which contains a literal value version 6. So, parsing things. Okay. Oops. Three bits labeled V are the version packet. 3 bits labeled T, the packet type. So it's either a so many rules in this one. I mean, I guess we can look at parsing this situation where we have a single packet that just contains a, or no, I guess this isn't a single packet though. This is, so maybe let's try and map this out here. So this is going to be version type, or sorry, no, I have to expand this to binary. Right. I mean, I guess the first thing we do is just expand it to binary. Let's see how hard that is to do in Ruby here. That was so hard. Okay, so that gets us our binary string. So let's just convert the string to an integer using base 16, and then back to a string using base 2. Now I've drank all my eggnog and should have enough sugar in me to get through this. Oh, I also installed Ruby 3.1 Preview 1 in hopes of playing around with YJIT later. See if it makes any of our puzzles faster. Though the only one solution that's really slow is day 15 part 2. It takes about 30 seconds. Oh, nobody's doing it in Python on stream. I used to do a lot of programming in Python when I was in my teens, but I found Ruby, and I thought, hey, this is so nice. Nothing against Python though. I just like Ruby better. I mean, I kind of want to just look at the binary and start mapping this out here. So, version, type. Type is 2, version is 4. So we know that this is going to be an operator packet. So the length type ID here is going to be 1. Call that I. or maybe L length type ID. 11 bits are a number representing the number of subpackets immediately contained in this packet. So 11, call it I, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it's telling us that there is one subpacket in here. So then we got VVV, VTT, right? And then I, so this is another one. So then, actually I want to put this on it's easier to read. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so there's one packet in here. VVV, TTT, I, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Tells us that there are, this is 0. Sorry, that our type ID is 0 here, which means the next 15 bits, I think that's 15. Oh, it even tells me in my editor. I don't need to count them myself. And so that's what, 1, 3, that's 11. 11, sure. That looks like 11. Total length in bits of the subpackets contained by this packet. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we have some trailing zeros, just 3 of them. And what do I do with 11 packets though? That's the part I don't understand. 11 bits of subpackets. Is this just another subpacket? Its type. Just make sure these line up here. So this one is type 4, which means it's going to be 1, 2, 3, 4, 5. All right, so we can tell if we parse this correctly manually just by looking at the version numbers, because I think we're just summing up these version numbers. So here we've got just these 3. So that's 6 plus 7, 11, 12, 16. Yeah, so we did that right. So we'll just manually do all that work for the for our puzzle input, which I'm sure is totally a size that we can manually do. Yeah, of course, it'll only take us a couple hours. I mean, it isn't so big we couldn't do it, but we're not going to. I never did any kind of parser stuff, so just trying to think through how we do this one now. seems like maybe we'll want to do like a little recursive thing where we build up some kind of structure. Okay, I mean we can create like a packet, initialize. I mean maybe the packet is maybe this is just a struct. Sorry, I wrote def there. That's funny. Is it keyword initialize? Ruby struct keyword initialize. That one. Yes. This version doesn't. This is not helpful. Let's keyword init. That's what I was looking for. And our struct is going to have some values like it's going to have version, it's going to have type, it's going to have we don't need to use a struct for this. Maybe we don't. Let's just write a bunch of adder writers, then we'll figure it out. Adder accessor. We want a type. We want a version. We want a length type ID. We want a length and we want subpackets, I guess. Seems reasonable. Seems like a reasonable bunch of things. So packets, or I guess packet equals parse packet input. I'm going to split this into, so it's just an array of bits as strings, whatever, that's fine. So we know it's going to need to make a packet. So the packet it's going to make is going to just be a new packet with nothing in it. I'm going to return it at the end. Let's use tap for no reason, because nobody else has to put up with my code. So we're going to use tap here to configure this thing. Let's double check our Ruby array methods. We want, I think we just want we want the other one. Unshift? No. Shift. Yes. So we know we want to, I mean, this is going to manipulate the packet data anyway. There's very little reason to actually pass the packet down. Oh no. Do we? I guess we just do it in a loop then. Instead of recursively. Anyway, so we know that the version is going to be the first 3 bits. So we could say packet data dot shift 3 join and convert it to an integer base 2, and we know that the type will do the same thing, and then the length type ID is just going to be the next one, so we don't need to join it. And then that's where we're going to want to validate that we're doing the right thing. Okay, so should have a version of, I think that was right, type ID, whoops, type is 2, I'll double check that, and length type ID is 1. Okay, that seems right. What was it? 4 and 2 and 1. So we're doing the right thing. So now we know that we're either going to have if it's 0, we need the next 15 bits. Length or it's sub packet count, I guess. It's probably the other thing that we can have. So if length type ID is 1, it's going to be 0. Actually, let's check 0 just because that's the order that's in the puzzle. Then we're looking for the next 15 bits. And that's going to tell us the, we should set these all in the packet that we're building. Packet dot, and this is the length. Otherwise, we are getting the sub packet count, and that's only 11 digits. At this point, I think there's probably some branching logic. Finally, after the length type ID bit and the 15-bit or 11-bit field, the sub packet appears. It's 3, 3, 0. I'm a little lost here. Where's the other one right? But this is 3, 3, 0, and then 1, 4. How do we only get? I mean, that's definitely 10. But how is that a sub packet? Oh, my brain. These don't look like literal sub packets. What the heck? What am I missing? I'm just like, I can't parse this. So that's a version number of 6, a type number 4, and so packets with the type, oh, and then it's going to be a 0 followed by 5. Oh, okay. Yeah, we're good. So we're not handling the case of, so So this is like if type does not equal 4, we do this, else we do something else. This is tricky. Glad I don't have much to do today. So the thing that I'm struggling with, or just thinking about right now, bits label, total length in bits of subpackets contained by this packet. So if it's 0, hack off that many bits and parse them. Otherwise, parse until you have that many packets. We could do that. So this means subpacket data is going to be equal to packet data dot shift packet dot length. Until subpacket data is empty, parse packet subpacket data, and I'm sure we've made a whole host of hilarious mistakes here, but and then here we do a similar thing, so we don't need to hack anything off. We just go until packets subpackets is packet dot subpacket, or not is. I don't know, this looks kind of right. Like, I'm sure I've made tons of mistakes. Type is, should be packet.type. length type ID. Did the same mistake here. Line 45. I said packets. Shift for nil class. Okay, so I use shift lots of times. Day 16, part 1, line 29. How do we get here? Show static. Packet data is nil here. Oh, I see. I see the problem. Okay, we called subpacket data here. It's actually assigned over here due to the magic of Ruby. Variable hoisting. It wasn't a error. It was just nil. It's gonna. Okay, so I think we just need to be able to parse. It's conceivable in this moment. See if we can get to there. Wrong number of arguments given. Day 16, part 1. On line 34. I don't know. Anyway, we can try and write this. So in the case where the packet type is 4, we're going to keep parsing off literal chunks until we have the number, full number. So packet, I guess, can also then have a literal value. Just put that in there. God, a lot to unpack in this, like a lot of stuff to jam into this thingy. Okay. Let's just remind ourselves how we parse literals. It's chunks of 4. So we'll set the value to be an empty string. We will enter a loop. In the loop, we will pull off 5 digits. I don't know, chunk. I do like this. Does this work? Packet data shift 5. Value, I mean, I guess value plus equals chunk, break if check is 0, and then set packet dot value to be equal to value joined and converted to an integer using base 2. Well, this shouldn't take that long. Running assigned but unused variable 23, eh? Oh, that's fine. I don't care about that. Oh, is this okay. Version 4 plus 1 is 5 is 10 plus 6 is 16. That looks like it parsed everything correctly, vaguely anyway. In that case, we just need to output version sum. So the version sum of any given packet is going to be its own version plus subpackets dot sum version sum. Cool, that works. See if it works for all of our other ones. Oh, we got some kind of failure. 22. So, wait. One failed. The others succeeded? Is that what I'm reading here? Yeah, okay. Well, that's intriguing. Make sure we didn't copy paste wrong here. That's supposed to equal 12. All right. Wow. Yes, I've heard from some friends that day 18 is similarly, if not a little more complex than this one. So in this case, we're getting wrong number of arguments given one expected 0 on line 39. Wrong number of arguments to 2i given one expected 0. It's probably because packet data is nil here. Or packet data shift is nil. How do we get ourselves into this boat? So data is in fact empty. Suggests we've made a mistake. We have a packet with type 0. Oh, we've made a horrible mistake here. up, up, up. Like 66. That doesn't sound right. Oh, not there. Like 706. Okay, so we've obviously made some kind of catastrophic parsing error, but it's only being triggered by this input. The other ones parse correctly. So let's take a look at the binary and see if we can step through this thing. Oh. Figure out where we might be going wrong. I'm just going to do buffer here. Try and figure this thing out. So we've got a version, we've got a type. Type is 1, which means then we have a 0. 0 means the next 15 bits are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 15. And this is going to be 1s, 2s, 4s, 6. Sorry, 4s, 8s, 16, 32. We have 64. And it's telling us that we have 64 bits here. We don't have 64 bits. Do we? Oh no, we do. So the next one is somewhere over here. Let's see. Eyeball it. There's 64. Is that right? No, one short. So that's 64 bits of, and it's going to be 0. Am I missing something? That's 15. So that's version type, also type 0, and then I must have missed something, because then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 15. Oh, I mean, maybe not. So this is whatever that is in. Whoops, terrible. Says 706. What am I missing? What am I missing? Contains 2 literal values. It's an operator packet that contains 2 subpackets. Each subpacket is an operator packet that contains 2 literal values. Oh, did I miss that? What the hell? Okay, well that's obviously not what I'm picking up. Remember, you're leading. Did we mention, was there a mention of leading zeros? I thought there was only trailing. Oh, thank you. Thank you. So, do this. The binary number is padded with a length of zeros until its length is a multiple of 4 bits, and then it is broken into groups of 4 bits. So what is it saying? It's saying binary number padded with leading zeros until its length is a multiple of 4 bits. Is that what all this is? 6 in hex would convert to 010 and not 110. Yes, I understand that, but I am lost on how that connects to this. Okay, let me just read through this again. Every packet begins with a standard header. The first 3 bits encode the packet version. Yes. The next 3 bits encode the packet type ID. These 2 values are all numbers. All numbers encoded in any packet are represented as binary with the most significant digits first. For example, a version encoded as the binary sequence 100 represents the number 4. Yes. Packets with the type ID 4 represent a literal value. Literal value packets encode a single binary number. To do this, the binary number is padded with leading zeros until its length is a multiple of 4 bits. Broken into groups of 4 bits. I mean that. But aren't I handling that just fine? I'm not clear on how I failed to handle that. But I also just can't parse this thing. So I'm not even seeing. Oh. I understand now. God. So as far as I understand it, then I think what you're trying to tell me in chat there is that when I'm converting the initial hexadecimal stream to binary, I'm leaving off the start of, I'm leading off the leading zeros of the stream because my streams are always going to start with 1 because of the way Ruby handles this. Got it. All right, that's easy enough. Let's just So now I'm trying to produce a this is silly, but why not? It'll work. All right, so instead of what we did, to parse this thing, we will split it into characters. Then we will map the characters through our hex map. Oh, we'll flat map them actually. So we come with flatten and okay. Tests pass. Do solve this thing. Come on, part 1. Yes. All right. Day 16, part 1. Thank you, chat. Thank you, AB. I don't know how to say your name, but thank you. It's one of those ones where like someone tells you the thing that you're missing and you're just like, I don't understand how that's the thing I'm missing. But I got there. All right, part 2. Now that you have the structure of your transmission decoded, you can calculate the value of the expression it represents. Literal values, type ID 4, represent a single number as described above. The remaining type IDs are more interesting. The value with type ID 0 are sum packets. Their value is the sum of the values in their subpackets. If they only have a single subpacket, their value is the value of the subpacket. Packets with type ID 1 are product packets. Their values are multiplying. Packets 2 are minimum packets. 5 are greater than packets. 6 are less than packets. 7 are equal to packets. Okay, big conditional time. All right, so we've done a pretty good job of this. We are going to have part, so this is what, part 16, sorry, day 16, part 2. And we know that rather than the version sum, what are we calling these? I'll call it expression value. I'm just going to call it evaluate, because it's shorter. Okay. So we've got these things. We need to be able to evaluate them. And it's just like, it's just going to be a big case statement when, so it's going to be based on their type. We already know when for, then we return value. I'm going to put an else in here. And I'm just going to go one by one here. Well, let's set up a test, actually. Unskip this guy. In fact, focus this one. Let's make a bunch of tests. Let's vim macro our way to a bunch of tests. So this is going to finding the sum of 1 and 2. write a macro to actually do the work here. Finding the product of 6 and 9. Finding the minimum of 7, 8, and 9. Oh, so much typing. I'm just going to put the context in. Maximum of 7, 8, 9. I think this should be pretty easy once I actually get in here. Finding whether 5 is less than 15. Whether 5 is not good. 5 is greater than 15. And finding if 5 and 15 are equal. Okay. And then we can do a quick macro. Let's hopefully ooh. Love it when your Vim macro works. Oh, that's gonna mess this one up, but I can just fix it. All right. I missed this one, which was tricky. Okay. Finding whether 1 plus 3 is equal to 2 times 2. All right. We have substantial test suite. We should be getting right in here to see like type and then having to implement the types that we're missing. So we can see type 1, we can implement type 1. And so let's look. Type 1 is product. Let's not one line all of these. That's going to be hideous. This is literal. I guess we can just put them all in. Two is minimum. I think that's maximum. 5 is it's greater than. Less than, and 7 is equal to. Okay. So this is just subpackets.sum evaluate. This is subpackets. Map evaluate, or I guess I can inject. No, I'll do it this way. evaluate, inject that. If subpacket first dot evaluate is, so it's first, right? The first subpacket is greater than evaluate, then 1, else 0. I assume this is going to be the other way, but who bothers reading things? And this is going to be equal. We shouldn't have any other types. But we did spell evaluate wrong repeatedly. Produces. Where did I write the word produces? Okay, so that works. Gives us a really big number. Yes, there we go. Well, that was relatively successful. There was a lot in there to unpack, but we got there. I think I'm just gonna roll into day 17. I'm told it's easier than this one, but if you're watching this on YouTube, thanks for watching.